So, I'm Morgan Gautreau. I will be your professor, and I also a YouTuber. I'll talk about artificial intelligence, machine learning, and data stuff. So we talk about a lot about artificial intelligence nowadays, but why? Why talk a lot about artificial intelligence, and why invest in artificial intelligence? It's because artificial intelligence will have a huge impact on how we live our life and in the next and future economy. So by 2030, artificial intelligence will create $13 trillion. But it's not that only that the amount, which is very huge. It's also the way that artificial intelligence will have impact in a very different field. So we can have impact on retail and on travel, on transport, logistics, automotive and assembly, basic materials, advanced electronic, healthcare, high-tech, telecom, oil, gas, agriculture. So, and a lot of other things like in education. So if you have data on a field, you can have an AI impact in it. Nowadays, you have a lot of impact in recommendation system. So it's very interesting if you sell products, but you have a lot of product to sell, like Amazon, like Netflix, thing like that, and you want your client to see only the product that is more suitable for him. Okay, so you will use recommendation system engine to propose only products that the clients and the customer wants. So it's for that when two people use Netflix or use Amazon, they will not see the same products. They will not see the same page. And sometimes for more advanced company, they will not see the same design of the website. It's due to a hyper specialization of the web. Okay. So there are a lot of research, a lot of projects in recommendation system engine nowadays. So it's a project to keep in mind. You have also a lot of application nowadays about natural language processing to better understand the text, because today with internet, your client, your customer, or your user leave a lot of textual message, and even if we are able to understand part of this message or part of this text, today only few application use your customer or user text, and it's a shame because when your user leave message to told you what they think about your products or think about your website or your application, you have to take that into account to make sure that your product is to create the best product you can to that your customer can enjoy. Okay, so it's part to so. I think I read somewhere that text now is the first saved information about user and is least used during the study and during the application phase. Okay. You have computer vision thing. So when we talk about computer vision, last time we thought about self-driving car. But when you unlock your phone with your head, is also a computer vision thing. You will have a lot of application in robotics, but not. But there is a lot of application in commercial use also. If you have, I don't know, a website, you can use and you sell product on it. You can use computer vision project to make sure that you will show to your customer, to your clients, only the best image, the best image for him, to be sure that he will buy a product. I saw this application on Netflix. Netflix, for every movie, they have a lot of different thumbnail, a lot of different picture, and they will change the picture for the time of the year. If you are around Halloween or Christmas, you will have different images. And if there are different type of customers that use the application, they will not see the same picture. For example, if they are more likely to see movie from a certain actor, will have picture with this actor from this movie, etc. With artificial intelligence, we can take into account sound recognition or sound. Today is not the most application using sound. It's not because it's difficult to use sound, but because a lot of company did not save sound, because you have to create products with mic on it, and with a way to store the sound, and you will have to have the right to record your user. Okay, so except certain company, not a lot of company have a lot of sound to solve their problem. So work with sound is not a difficult problem, but get enough data of sound can be is often the main problem. When we work in artificial intelligence, most of the people thought about reinforcement learning. So reinforcement learning is to create agents that is able to learn from a simulation how to solve a task by itself. So it's great to learn how to win a game. So reinforcement learning is used to create application to AlphaGo that win game against Lee Sedol, which was world champion of Go. You have Alpha Chess that beat anyone who play chess, and more currently there are also other achievements from reinforcement learning to beat people using playing much more complex video games than Go. But in fact, in real world, there are not a lot of reinforcement problem. It's being used for autonomous learning and self-driving car, but in most of the company, there are not a lot of use case of reinforcement learning. So today, nowadays, reinforcement learning is still I should say is still locked into the research field. Okay, there are some application in company, but most of the time will not use reinforcement learning. Okay. When we talk about artificial intelligence, what we need to do is to make the difference between artificial intelligence and general artificial intelligence. Artificial intelligence, and sometimes is called artificial narrow intelligence, is what we use today. For example, we have an image of a cat, and we can train an artificial narrow intelligence to say in this picture if it's a cat or not. Versus general artificial intelligence, which is subject for sci-fi movie, science fiction movie, okay, like in Matrix, like in Terminator, anyway. So artificial narrow intelligence can solve very specific problem and cannot be adapted to other problem. And general artificial intelligence can do everything a human can do. It can, for most of the people working in this field, is very common. Okay, everybody knows that, but nowadays with the breakthrough of ChatGPT and the AI artist, there is more and more people that fear of that researcher creates a general artificial intelligence that can doing everything a human can do. It can rule the world, but we are very, very far from that. In fact, I don't know, but 99% of the research is focused on artificial narrow intelligence, and there is no sign yet that we can achieve general artificial intelligence. And if we wanted to build a general artificial intelligence, we need technology that is not developed yet, and we don't know how to unlock it. Okay. So to better understand artificial intelligence today and why we use this kind of technology, we need to understand artificial intelligence through time. Okay. So what is artificial intelligence? So artificial intelligence is a field of computer science whose aim is to create and simulate programs that perform tasks normally performed by human intelligence. And in artificial intelligence, you have different fields, like expert system. An expert system is a computer system emulating decision making and ability of human experts, and is the first field of artificial intelligence. So it's created in 1957. And what is system experts? A system experts is a rule-based system. An expert system is a program that answers questions or solves problems in a given knowledge domain using rules derived by knowledge of human experts in that domain. So you have a database with a lot of rules, so how to solve a problem. So you have rules, here you have some constant, you have some database, and here when a user want to solve a problem, they will use an inference engine. Okay. Inference engine will use some information from the rule base and from the database to create an answer that will send to your user interface to send back to the user to solve a problem. So building system experts, we need an expert that solves the problem in a real life, So I don't know, if we want to create a system that is able to predict the price of houses, okay, to create an expert system that can achieve this, you need experts when his day job is to estimate the price of houses. Okay, so you need an expert and you need a developers. The developers will ask questions from the expert and will ask like how he does to estimate the price of houses, and he will list different rules to know how these experts estimate houses. So he will make some acquisition of knowledge. The expert will explain how he do. Okay. He will create an inference engine. Okay, that's which derive from the acquisition and of knowledge, and writing some rules from this acquisition knowledge that will operate with this engine inference. Like that, when a new person wants to know the price of a house, he will ask from the engine inference. This inference engine will base is a result from the rules that the developer is writing to answer to the user the price of a certain house. So at this time, at that time, so 1957, there was a lot of application from system experts. So blood analysis diagnosis. So if you have a blood sample and you can measure the sweets in the blood and a lot of other things, if you have sweet at a certain level and another component and another level, you can say, okay, you have a good blood analysis or bad blood analysis, and you need to see a doctor. So you can have applications that can make explainable and diagnosis from the blood sample analysis. You can troubleshooting for car. You can checking aircraft before the aircraft the plane take off, and even today when aircraft are leaving, most of the aircraft still rely on system experts to check all their system before taking off. You can have also in automated assembly line. And why we are still use system experts to check system? Because when the aircraft is finished to be constructed, and now the number of the system did not change much, so the way to check all the system will not have some difference. So if you are listing all the rule, all the condition to check the system, it will not move anymore after. So you can when you create your system experts, it will be, you can use it for all the I don't know say, during all the life of your aircraft, to check their system if they are good or not. So there is some pro and con to use system experts. Pros before. System experts use common sense to solve a problem because he choose the rules of an expert to solve the problem. Okay, so when people when you want to know how the system take a decision, you will have the system take common sense to solve the system, so you can know how it takes this decision. it perform good in closed environments. Closed environments, that's environments will not evolve through time, like checking the system for an aircraft. The system will not evolve much through time. Okay, so you will not have to create every month new rules to adapt to the evolving environment. It's an interpretable model. If the model say, okay, there are systems that have problem, it can say why it thinks the system have a problem. So it's interpretable. So it's very interesting. But you have some cons. It's time consuming to set up. If you can solve the problem with, I don't know, 10 rules, it's not time consuming, so it's okay. But for some problems, you can need like thousands of rules to be sure to completely understand the problem and solve every case of the problem. So to maintain is difficult because when you have thousands of rules in every direction, it's difficult to know that adding another rules will not break the entire system. If you work in an open environment, I don't know, maybe like if you create software that give an answer for loan, for risk loan. If you have a bank, you want to give loan to people and create systems that say, okay, you can have a loan, or not okay, you can't have a loan. So the environments, the economy, the people behavior change through time. So the environment is changing constantly. So if you want that your software keep up with the change of your environment, you need to add new rules every month. Okay, and so the maintaining is very difficult because you have to add new rules, make sure that you will not break old rules, and to make sure that your software is still accurate and it still have a good performance. Okay, and system experts have a biased approach. Why? It's because your knowledge in this model derive from a knowledge from an expert. So the expert will tell you how he does to solve the problem. But we are not sure that the solution of the method of these experts is the only method and also is the best method in the world. Maybe these experts use this method to estimate the price of a flat of a house, but maybe it's not a very good method. So you create a system expert that solve the problem, but not in an efficient way. So after system experts, people try to create another way to solve problem in artificial intelligence using fuzzy system. So fuzzy system, another way in artificial intelligence to solve problem. Fuzzy logic is an extension of Boolean logic, which allow the modeling of data imperfection and comes close to the flexibility of human reasoning. So we are still in the way to try to create rules, create a system that reflects human reasoning and reflects how we solve a problem. For example, here you have some water. You can have hot water and cold water and mix a tap. And the problem is topping up the water level in a bank containing water at one temperature, so as to fill it with water at a desired temperature T using a mixtape. But how we can do that? How we can achieve that without a thermal temperature? So here we have TH, which is the temperature of the hot water. It is the air temperature for the cold water, TC, and TT is the temperate water. Here we have margin error because we don't know for sure at which temperature is the hot water, cold water, or temperate water. We can touch the water and say here, for sure, here we have cold water. If we are above T2 of temperature, we don't know the temperature for sure, don't know the number, but we know that it's hot water. Here, if we touch the water, we say, okay, we don't know for sure if it's temperate or hot, but it's between temperate or hot. And here, if we touch the water, we know that it's not cold, it's not hot, it's between colder and temperate. So here we have a value between 0 and 1 if it's cold or temperate, and here if it's temperate or hot. But here we are sure it's hot, here we are sure it's cold. So this is what I said before. Here, if it's below T1, the water is cold. If T equal TT, the temperature is temperate for sure. If it's above T2, the water is hot. But here we can hesitate between cold and temperate, and here between hot and temperate. So to solve the problem with fuzzy logic, we can control the mixing valve is therefore simple. If the tank is cold, use hot water. If it's temperate, use temperate water. If it's hot, you can use cold water. So we have different application with fuzzy experts, fuzzy system. We have decision making and diagnosis supports. Application in a database. We have shape recognition and multi-criteria aggregation and optimization, and fuzzy system control. Pro and cons: it's using common sense. Is a condition can be in other states than true and false, so it's between 0 and 1, so it's very advanced from the old system experts. Flexible of reasoning, making it possible to take imprecision and uncertainty into account, and the model in interpretable. So we have some cons. So time consuming to set up, difficult to maintain also. Constant is difficult to model constant updating open environments, and the approach is biased from how we create our environments to create our fuzzy system. But in 1970, we start to talk about machine learning, and it's very, very important because nowadays when we talk about artificial intelligence, like most of the time, I don't know, but maybe 90% of the time, the model, the solution is based on machine learning. Okay, so it's very breakthrough in 1970. So machine learning in another field in artificial intelligence, and machine learning, or ML, is a branch of AI. It has the ability to learn from data using a learning algorithm, the aim of which is to perform explanatory, predictive, or preventive analysis. So machine learning learns through data, okay, but how it learns? We have data, we have a model, and we made a prediction using a model. For now, this model is a black box web. We will see in the next video, in the next lecture, what is inside this black box. So it's used data, but what is data? Data is information from an object of study. So information that we can measure. For example, For a house, number of room, the surface of the house, if there is a garage or not, etc. Here is what we call structured data, because it's data that we can store in a table form. Okay? So from a data we can create database. Database is when we can store multiple observation and variable. For example, here is my object of study, is my one observation, one houses. I can store here the number of room of this house, here the surface of this house, and if there is a garage. But I can do that with another house. Here, 3 room, 30 meter square. Yes, there is a garage. Another house, 7 rooms, etc., etc. And we can do that for every house we want to measure and extract information. So here, for every column we'll have a variable of our study object, and for every line we'll have an observation of our object state. For example, you will have for every line a house. So how we train an algorithm from machine learning algorithm, how we train a model. Here we have our training data with our previous database. We'll use a learning algorithm to extract from our training data some correlation, some information to how to solve a problem. For example, estimate the price of houses. Okay, this learning algorithm will output a mathematical model, and this mathematical model can, from new data from a house that we don't know the price, make prediction, make an estimation of the price. So here is the most interesting part. So from data of house that we know their price and some information about the house, we can create a model that can estimate the price from data that we don't have the price. So it's very interesting. We can use different way of learning to solve different problem. No, so in machine learning we have 2 kind of problem, very different: supervised learning and unsupervised learning. And from supervised learning you will have 2 different application: classification, when we want to put observation into different class. For example, we have an image and we want to know if it's a cat or dog. So cat is a class, dog is a class. And regression is predicted a continuous variable. For example, the price of a house, it can be from 0 to infinity, or I don't know, the speed of the wind. Okay. From unsupervised learning, you have also 2 different applications. Clustering, so is to detect the inner information from your data to create groups. So we'll see after the difference between classification and clustering. And here, dimension reduction. So if you are in a high dimension, how to use model algorithm to reduce the dimension of your problem from n dimension to, for example, 2 dimension, to be able to see your data with a simple graphic. Okay. So we'll start with supervised learning. What is supervised learning? Here you have your database. For example, information from house. And here we have our target variable, what we want to estimate. For example, the price of houses. So here is label data. And supervised learning, the aim is to create models that will use explanatory data to try to predict the target variable. So if you want supervised learning, you need to have labeled data, explanatory variable in one hand, and target variable in the other hand. But how we train a model? So we have our data, we have our model, and at the start, this model is filled. There is a lot of different parameters, and they all random at the start. So if you give data to a model which is random, it will output a random prediction. So what you will do, the aim is to estimate y, and you predict a random y. You will compute the error, so the distance between what you need to have to form answer and what you have estimated. And you say with this error, you will have to make an update to the model parameter in a way that I will change the parameter that for the next time you will see this kind of data, you will predict y hat that it's much closer than y, and you will do that for every observation of your database, and in a long time, and with long training. After a long training, when you will give different observation, different variable from one observation to your model, you will estimate a y hat which is very close to y. Okay. A very interesting characteristic of a machine learning model that is easy to update. If you are working in an open environment, for example, you want to send an email to people that want to buy your product, okay? And you want to create an algorithm that selects or detects the people in your customers that want one product. This kind of people, maybe this behavior will evolve through time. Every time you want to excuse me, every time you want your model to be closer than the behavior of your client, you will just have to store data of the current behavior and train again another model. Excuse me again. But the learning algorithm to create your mathematical model, for creating your mathematical model, you have choice between different algorithms. Okay, you can have algorithm based on tree decision approach. You can have model based on linear approach. And you can have model based on distance approach. Okay, so during this course, during the further lecture, we will see into the foundation of this three different type of model. And this model can be used to solve two different type of problem. Regression problem, you use explanatory variable to try to predict target continuous variable. So it's regression, for example, estimate price of houses between 0 and infinity. And classification, for example, you have information about patients, and you want to detect if they are is there a cancer or not, or disease or not, is classification. You want to predict different diagnoses. To use machine learning, a common machine learning system, for example, in healthcare company, you have object of study, for example, a human being. You will make some measure and examination from this human to extract information. But for example, the weight of the age of a patient is structure information, so we can store it in a table, okay? But an image or blood sample, or here an image too, biopsy, cannot fit into structured data. We call that sound, image, video, text. We call that unstructured data. So it cannot be easily understood and efficiently take into account into classic machine learning model. So you will have to make yourself an extraction of feature to transform your unstructured data into structured data. For example, if you want to know if the certain person have a cancer, you will look at the cell and maybe count the number of cells that is secure and count that number of cells that could have been a cancer cell. Okay, so you have to find a way yourself to extract information, structured information from your unstructured data. In unsupervised learning, here it's not supervised. So before you have explanatory variable and target variable, and the idea is to transform your explanatory variable to a target variable. Now we don't have target variable. We have unlabeled data. Okay, so we have explanatory variable, and we want to understand and to find the inner structure from our dataset. The first problem is clustering. We'll see in the classification and clustering we talk about classes, but it's not the same problem. It's not the same algorithm. We'll see now the difference. For example, here classification we have X and we want to predict Y. We have label data. So here we have round blue and here round green, and we want to learn how to go from X to Y. Here is to create a model that can separate quickly and efficiently our two classes. In clustering is different. It's unsupervised data. So we have unlabeled data. Imagine you have this data set, so same that previous, but you don't have the information that this round is blue and this round is green. So you want to learn the hidden structure of your data to maybe regroup this data into one class we will call blue and one class we will call green. For example, here we have information about our customer is the number of email that's our customer open, and here it's average basket of our customer, and our model can say, okay, this kind of customer have the same behavior, and this customer here has the same behavior. So we'll create two classes, a class here red and here blue. Okay. And we have two different algorithms to try to solve the clustering problem. We have here what we call a Kamin algorithm, hierarchical clustering algorithm, and a Gaussian mixture algorithm. And the second problem in unsupervised learning is dimension reduction. For example, here we have data set in three dimensions that we have three different variables in dataset. It's difficult to represent, and if you have more than three dimensions, for example 4, 5, 6, it's impossible to visualize. So dimension reduction is to reduce the number of features, reduce the number of dimension, and in the same time conserving the most information possible in these two dimensions. Like that, you can visualize your data in 2 dimensions only. So pros and cons of machine learning. Pros. You can learn from new knowledge. So before, from fuzzy system or expert system, you extract knowledge from experts. So the experts have all the knowledge, and during the process of creating your model, you will not gain much knowledge, much more information that you have at the start. Here you will extract information from your data, so you can gain knowledge. So how your clients behave, how, I don't know, for example, for the estimation of house, maybe your experts only rely on three, four variables to estimate the price of a house, and maybe the algorithm say you rely mostly on the number of bedroom, but the global number of room is more important than, I don't know, the surface per room. So if you want to have a house more I don't know, if you want to sell the price your house at a higher price, you will have to divide your room into multiple more room. It will have higher price. So things like that. So your model can give you more insights and more knowledge about the problem you want to solve. The model in certain way is still interpretable. If you take a decision, you can still know why your model take one on other action or decision from the model. Is easily maintainable, even if you have a constant evolving algorithm environment. If you want to have a model that is closer to your environment, what you will do is to collect a sample from the new behavior and just retrain a model. So if you want to have a model that is always at the state of the I don't know, always closer to your customer, you can train a model every month with new information from your customer. But we have some cons. For example, machine learning algorithms have poor performance on unstructured data. Like we know, like I said before, unstructured data is images, text, sound, things like that. It cannot fit into a table. So we have to ourselves to extract information, and so we lose a lot of information. It's a biased approach to work with unstructured data, because we have to select ourselves what information we think is a better information to solve the problem. But sometimes the most useful information are information that we don't think to extract. So it's a biased approach, and we lose common sense. Why? It's maybe it's a machine that take a decision, and sometimes machines have a lot of can have lot of performance in very difficult problem, and maybe make an error in a very easy problem for a human. And it's that, it's a lot of common sense. It will not solve the problem like a human solves the problem. Okay, so this is a lot of common sense. So this first part is finished on fuzzy model, expert model, and introduction to machine learning. In the next video, we'll talk more about deep learning and the fundamental difference between machine learning and deep learning.